Hello everybody, good morning and welcome to Smart Mentor Tutor, and I hope you are keeping safe. Today we are going to talk about another topic, but before I go into the topic, I would like to share our behavioral objective with you. Now some of these fatty acids are present in what? They are present in animal fats, also in citrus fruits, oils, for example, palmitic, stearic acids found in most common oil. Therefore, we'll be talking about, well, I don't know yet, but let me tell you that the fatty acid that we're going to be talking about, you can have them in what citrus, what fruits, like what I have here. These are orange juice, and this orange juice, I told you before, contains what we call ascorbic acid, with what? A functional group for what? Carboxylic acid. You can have inside it, you have what we call saturated fatty acid and the unsaturated fatty acid. You know when we're talking about saturated fatty acid, meaning the carbon to carbon bonds are single bonds. Meanwhile, in the unsaturated fatty acid, automatically you are going to see one of the carbon to carbon bonds being bonded with what? A double bond. Yeah, that are what differentiate between saturated and unsaturated fatty acid. All these are present in what we call oils, citrus fruits, animal fats, and animal fats. Good. Therefore, in the drinks we take, I won't lie to you, we're taking saturated or unsaturated fatty acid. Now, what is the topic? The topic is what? Fats and oil. And what is our behavioral objectives? We are to list the source of what? Fats and oils, to state the physical properties of fats and oils, to explain the hardening of oil, to define saponification, explain detergent and the soap, then list the advantages of what? Detergent over soap, then to prepare soapy detergent, and to prepare what we call soapless detergents. Then practical on soapy and what? Detergents are required. We are going to do this as well. And aside this, we're going to be talking about the test for fats and oil. This is what you should be able to know at the end of the class. Now, let's talk about detergents and soaps. What are detergents? When you say detergent is a chemical compound, you know when we're talking about chemical compounds, or a mixture of what? Compounds used as a cleaning agent. Chemical compounds, we're talking about what? Compounds that are chemically combined together, and we use it as what? A cleaning agent. E.g., our normal detergent is area that we use to wash, Omo, the likes. We call them what? Detergents. Now, soap is a cleaning what? Agent as well. But it's totally different from what? Detergent. Yes, it's a cleaning what? Agent that is composed of one or more sort of what? Fatty acids. It's a cleaning agent that is composed of one or more what? Sort of what? Fatty acid. Underline this word, sort of what? Fatty acid. That is the sodium sort of fatty acid or the potassium sort of fatty acids. And the example is what we have here. Our normal solid soap that we use at home to wash our clothes. Now, let's quickly talk about the sources of fats and oil. Lipids are collective name for both fats and oils that are used by organisms for long-term energy storage. Lipids are collective name for both fats and oils that are used by organisms for long-term energy storage. Look at it here. Look at it here. Therefore, basically, we have what we call polyunsaturated what? Fats. When you're talking about polyunsaturated fats, we're talking about those that are made from what? Unsaturated fatty acid. And the sources, we can find this in our fish that we eat, seafood, then polyunsaturated what? Margarines. We have our vegetable oils, such as sunflower, corn or water oils, nuts such as walnuts and the Brazil nuts, and seeds. Yeah, these are where we can find our what? Fats. Then let's quickly talk about the what? The physical properties of what? These fats and oil. When you're talking about physical property, we are talking about something we can feel. We can use all our senses to determine. Fats and oils are colourless, odourless, and tasteless. That is the first thing. They are colourless, odourless, and tasteless. What you are going to ask me that most of the oils that we see around, they are not colourless. Why are they not colourless? You need to note that any colour or taste is due to the association with other foreign what? Substances, e.g. the yellow colour hair or body fat or milk fat is due to what? Carotene pigment that is present. Then therefore this particular vegetable oil you are seeing with what? A yellow colour is as a result of what? Carotene pigment that is present in it, not because it is an oil. Because if it is an oil, it should be colourless. Now let's talk about their specific gravity, how heavy they are. They are less than 1. That is why they float on water. I don't know if you have tried it. You can put small oil in water, you discover that it floats. To float on the water. Why? Because of the what? Specific gravity that is less than 1. Yes, they are insoluble in water. I hope you've done this before. These are things you can do at home. You can put your oil inside water, but soluble in organic solvents. Well, you may not have these organic solvents, but in the lab we have them. You can put the oil in what? In benzene what? Solution and see what, or ethyl solution and see what is going to happen. What we are saying here, because oil, these are not polar solvent and the oil too is not polar. By the time you put not polar into what? Not polar into what? Organic solvent that are not polar as well, it will get dissolved. But if you put the non-polar substance into what? The polar solvent, it will not dissolve. That is why we say it is insoluble in water. Then the melting point is low, but the what? But higher than the what? Solidification point. We are talking about the solidification point, about the point at which those liquids start to what? Solidify. Therefore, what we are saying here, the melting point is always lower than that of the what? Solidification point. Good. Can we turn oil to what? Solid? Yes, we can turn oil to solid, and this process is what we call hardening of oil. We can what? Adding what? Oil. Why? Because the oil here we're talking about contains what? Unsaturated what? Hydrocarbon, and the meaning of unsaturated hydrocarbon means it has what? Available electrons that it can use to what? Accommodate a reaction, especially a chemical what? Reaction. Therefore, hydrogenation of oil is the chemical process of adding of what? Vegetable oils. That is what? That is forming margarines in the presence of what? Catalyst. And that is what you are having here. This oil, what happened to the oil with what? Adding the oil in the presence of what? Catalyst. With adding the oil by what? By the addition of what? Hydrogen. That is what we call it what? Hydrogenation. By the addition of what? Hydrogen, and become what? Saturated. By the time it becomes saturated, it turns to what? Solid, and that is what? Becomes fat. And the product you're having here is what? Margarine as what? As solid. Therefore, this can only be possible in the presence of what? Catalyst at a temperature of about 200 degrees Celsius. Now, let's quickly talk about the hydrogenation of oils. Add what? Hydrogen gas to the carbon atom on the double bond. which I've explained before. What happens? Close up the double bond and make it what? A single bond. And when that happens, what happens? It increases the what? The melting point. As it increases the melting point, then it becomes what? Solid. Produce what? Solid, such as what? Margarine, such as what we call what? Margarine. This what we call what? Margarine and what? And shorten the what? The carbon to carbon bonds. Now let's now talk about saponification. What do you mean by what? Saponification. What do you mean by saponification? Yeah, basically when we're talking about saponification, we're talking about the alkaline hydrolysis. You need to understand what we mean by hydrolysis. Alkaline hydrolysis of what? Fats or oil to produce what we call soap and what? Proper 1, 2, 3 triol. The raw materials are the raw material is fat and oils and what? And the alkaline. Now I talk about to remove the what? Glycerol, because this particular glycerol you are seeing is a waste product. Sometimes they've converted this waste product, they've converted it and make it what becomes useful products like some chemical industry. But in order to remove this glycerol, what happened? The resulting soap and glycerol could be what? Sorted out by adding what we call sodium chloride. Sodium chloride, you still remember, it is salt. That's why we say sorted out by adding what? Sodium chloride. Making use of the fact that the soap is what? Less soluble. When the soap is less soluble, it means it takes a longer time for the soap to get dissolved in water. In a what? In a salt solution than in water. It's less soluble in a salt solution than in water. Therefore, what happens? By the time you add the salt, the whole process is called hydrolysis or what? Esters. But you need to understand that by the time you now add the what? The salt to what? To the soap. What happened? Because we said it is less soluble in what? It is less soluble in salt solution. Then the precipitate will be what? The glycerol will be precipitated what? Out. It should be what? Precipitated what? Out, and you can then collect it and the whole process was continues. And this is what we call hydrolysis of what? Ester. Now, when you look at this particular reaction, this glycerate tristearate. This is a fat, this is a fat, then this what? There is a sodium hydroxide, and we say hydrolysis, we are adding water to it, and what happened here? See what has happened here? All this particular thing, what has happened here? Yes, this, and this. Okay, this and this, what happened? This mine, okay, this mine, this minus, this plus, then this minus, this plus, then this what? Minus. You need three moles of what? You need 3 moles of hydrogen of what? Of 3 moles of what? Hydrogen. Or let me say everything is going like this. It's going like this. To replace, and this one is going, but then this one, then what happens? So it comes to this place. And comes to this place. For a complete reaction of this, to form, that will form this. Why the other one? Why? This one. Forming that. Why? This one is forming this. Actually, this is what we call soap. This is what we call soap. Why this is what we call glycerol. Another name for glycerol is 1, 2, 3. That's what I told you is that is propane. This is propane. You name this as propane. Then you now indicate the position of the OH. 1, 2, 3, 5. Oh. Now, in order to remove this, we use what? We add sodium chloride to it. And what happened to the sodium chloride? Because it is less soluble in the salt, it will be what? Precipitated out or resorted out. Then you have your what? You have your soap. Now let's quickly talk about the advantages of detergents over soaps. Detergents clean more efficiently in hard water than in soap. You know, when we're talking about hard water, we're talking about water that contains calcium 2+ or magnesium 2+. Yes, therefore it cleans more effectively in hard water than what? Soap. No, than soap, because hard water contains calcium and magnesium ion that what limits soap cleaning ability. That limits what? This particular one will limit soap cleaning ability, but here it contains and make it more effective to clean or to remove dirty particles. They are more soluble in water than soap. You can try this. Put a little detergent in water. Put a little detergent in water and put a soap in water and see which one will dissolve easily. This one will dissolve more in water than in soap, and hence form more lather than soap. You see a lot of particles on this particular one when you use detergent than when you use soap, and they are very cheap. You know, when you compare it to to soap, because when you are talking about detergent, it's made from waste product of crude oil. You know, the waste product gotten from crude oil is what we use in making detergents. Therefore, they are very, very cheap in the market. Then when compared to soap, these are advantages of detergent over soap. One is they clean more effectively in hard water because of the presence of calcium, magnesium, ion than soap, because soap doesn't have this, and that limits its cleaning ability. Then when you put detergent in water, it dissolve more easily than when you put soap in water, and when it dissolves easily, it forms more lather, and it is the lather that removes the dirty particles in clothes. Then aside this is cheaper when you compare it with soap. Good. Now, facts about detergent and soap. Let's quickly share some facts about detergent and soap. When we're talking about detergent, the major disadvantage of detergents is that they are non-biodegradable, meaning that the microorganism cannot reduce them to pH minimum, because they are made from petroleum products, which is not renewable. Good. There is another perspective to it. When you talk about petroleum products, they are not renewable. That is why we say when you keep extracting it, you get to a point that it will dry up. It is not renewable. And aside this, it causes soil and water pollution. Yes, because by the time you pour the detergent water into the gutter and get to the soil, what happens? It reduces the nutrients of the soil, thereby causing death to that particular soil, to the plant that is planted on the soil. Meanwhile, equally, when you pour them in the gutter and to the river, and what happens? It causes what we call water pollution, because it will reduce the dissolved carbon dioxide and the dissolved oxygen present in the water. And what happens? The fish will find it so hard to breathe, and which can result in death of that particular fish. Then the new soapless detergent molecules. The new soapless detergent molecules have been designed so that they are biodegradable by making the alkyl group. By making this particular alkyl group. By making the alkyl group a straight hydrocarbon chain of carbon atom, as shown below here now. Then the new soapless detergent molecule has been designed so that they are now becoming biodegradable by making the alkyl group a straight hydrocarbon chains of carbon atoms, as we have it here. Now, what happened to soaps? Soaps are biodegradable since they are made from plant and animal products. Good. Now, let's quickly talk about the soapless detergent are made generally from petroleum products treated with concentrated tetraoxosulphate 6 acid. This is shown. The soapless detergent are made generally from petroleum products treated with concentrated tetraoxosulphate 6 acid. The general method as shown beside here. Okay, let's see. The general process involves initially the reaction of a long straight chain alkenes, such as deodecane. This is deodecane with benzene. This is benzene. This is deodecane, and form deodecyl benzene. It's form deodecyl benzene. C6H5, C2, H11, CH3. How many carbon? 6 times 17 times 18. This C11 plus 6. 11 plus 6. That will give you 17. Then you have 18. Deodecyl benzene. Good. The molecular formula of deodecyl benzene is 618H30. 618H30, and this compound is then reacted with concentrated sulfuric acid to give a compound that is known as sulfonic acid. Deodecyl benzene. This is deodecyl benzene, which is that is 618H30 plus tetraoxosulphate 6 acid to form what we call deodecyl benzene. Benzene sulfonic acid. Deodecyl benzene sulfonic acid with water. Finally, it is reacted with sodium hydroxide. When it is reacted with sodium hydroxide, what happens? Sulfonic acid. By the time you reacted with sodium hydroxide, then this one will go with this. Then you have You have C18. C18, you have H29, H29, S, O, T, minus, and A plus. This is what we call a complex detergent. This is what we call a complex detergent called a soapless. Sorry, this is what we call a soapless detergent. These days, soapless detergents such as this are to be found in most washing washing powders and liquids. Okay. Then you have sodium stearate as the soap. Talking about production of soap now, or action of soap. Yeah, soap is made from sodium water decanate called sodium stearate. Now when you look at this particular one, this is what we call the long chain what alkyl group, and they are not polar because they carry no what? They carry no charge because it does not contain plus or what? Minus. They are also called hydrophobic, that is water ether. Water what? Ether. Why this side here is called the edge, and it's called what? Hydrophilic. Hydrophilic means what? Water lover, and it's what? Polar. Why? Because it contains iron. The polar group is responsible for the formation of what? Emulsion. The soap mixed with what? Water, and the polar head assemble to form what we call charged sphere called what? Micelles. Yes, look at the micelles here. These are the micelles. Look at them here, called what? Micelles. A soap solution has a lower surface tension, meaning it doesn't create more pressure on the surface than water. Yes, why water is having more? Because of its what? Hydrogen bonding in water molecule. Therefore soap to dissolve what? Death. Therefore soap dissolve what? Death. Now what we're talking about here, we're saying soap, we're talking about having what? A low surface tension than water. Therefore when death comes in, it easily attack the death and remove what? Death. Unlike when you have soap and water. Therefore, the lower surface tension of soap will allow it to remove dead particles in water, because water is having more surface tension or higher surface tension due to its hydrogen bonding. The mixture now, when you now have a mixture of fat and oils, meanwhile they are not polar what? Dissolves in what? Non-polar grease what? Death. While the polar head dissolve in what? In water. Now when you have a greasy oily what? Clothes, what happens? The oil itself, the fat and oil itself is not polar. And the soap too, it has what we call a non-polar what? A non-polar group. Then what happens? You equally have what we call a polar head. Therefore, the polar head dissolve in water. The polar head of the fats will dissolve in water, while the non-polar head of the fats will dissolve in non-polar greasy what? Death. That one will dissolve. This will dissolve this, while the polar head will get dissolved in water. On the other hand, the hydrophilic ionic head group of the soap is not attracted to the grease. Why is not attracted to the grease? Because the grease is not polar, but it's strongly what? Attracted to the what? Water molecules. Because why? The water molecules is a polar solvent. When water is stirred, the grease is slowly what? Removed and is completely what? Surrounded by what we call a soap molecules. The grease is removed and was surrounded by what? A soap molecules. This is the grease here, surrounded by what? A soap molecules. And the grease is therefore solubilized and removed from the what? From the dish. This soap is able to remove the what? Grease, because of the combination of covalent and ionic bond present in water. Now look at this particular thing. Now what they are saying here, this is the grease. This is the grease. This grease has what we call polar and non-polar. And non-polar. This is the tail. And this is the head. Now what we're saying here is, in this particular, then the water we're putting it inside the water. And now you need to understand that the grease is fatty acid. The grease is coming from fat and oil. Fat and oil. It's coming from fat and oil. Meanwhile, the soap is coming from sodium octacanoate what? It's coming from octadecanoate, which is having what? The head too and the tail. Now, when you look at this particular thing, what happened? This one is not polar. This is not polar. This is not polar. The non-polar will go to the what? To the tail of the soap and begin to fight each other. You understand? But the problem is this is able to remove this particular grease, because this particular grease is coming from fats and oil. It's able to remove this particular grease because the soap has what we call a lower surface tension than water. And what happened? Because of its lower surface tension, if you move the grease to the surface, it's moving the grease to the what? To the surface. See the grease here, it's moving the grease to the surface of that particular cloth, then being surrounded by water. You know, water is what? A polar molecule being surrounded by what? Water. Now, what happened? The other end of the soap is what we call a polar. That one will go to what? To what? Water molecules. See, the soap molecules surrounded the grease, and this particular soap molecules and what? Water molecules. What happened? They get what? Solubilize, because it becomes soluble, because both of them can now react together. You know, polar and polar can react together. And what happened? In the course of reacting together, they remove that particular what? Grease that is already on the surface of the dish. And what happened? This is possible because when you look at it, there is what we call ionic bond from the water molecules and the head of the soap, and the covalent bond from the tail of the soap and that of the what? The fat and oil. And you even remember if it is in detergent. Okay, when we get to detergent, we talk about that. This is how it happens. And you need to understand the concept that soap is having head and the what? The tail. The tail, we call them hydrophobic water eater, while the head is hydrophilic water lover. Meanwhile, the water itself is polar solvent. Now, by the time you now put a plate that has grease, it's coming with what? Non-polar. It's coming with what? Unsaturated what? Fatty acid. This unsaturated fatty acid, they are not polar. Then the oil from that particular plate will go down to the what? To the tail of the soap. We react together. Why? Because now the soap is what? Is having lower surface tension than the water. It will make that particular grease to come to the surface of that particular plate. That is force achievement. And when it gets to the top of that particular plate, it will now be surrounded by the what? By the what? Soap molecules. That oil will now be surrounded by what? Soap molecules. Now, the head of the soap will now come in contact. The head of the soap will be surrounded with the water. Then both of them react together to become what? Desolubilize, meaning that they react together and remove that particular plate that has already been on the surface of that particular what? Plate. And this is possible because of the combination of the covalent what? That is from the tail, soap, and the grease, and the ionic bond that is present in the water. There is the ionic bond between the water and the head of the water. So, and that's what happens. See the way they now remove it. Then the grease separate from what? Surface, and it is held in what? Suspension, which can then be what? Washed away. Now, test for what? Test for fat and oil. Now, for us to test for fat and oil, what we need small amount of fat, we need the filter paper, we need the what? Sudan tray. Now, test one, you can place a small amount of substance on the what? Filter paper. Place a small amount of what? Fat here. And what? And rub or warm or melt, what happens? You are going to see a spread of what we call translucent spots will be on the water paper, and that show the presence of what? Fat. Or we use what? Student reagent. When you have student reagent and you put fat here, you put the fat here, then you now add what? Plus you add student reagent to it. When you add to the fat, what happens? You are going to see a red color. You are going to what? You see a red color is observed, and this red color that is observed shows that fat is present. I hope you enjoy it. If you